Greetings, this is the man who pretends to be Charles Darwin, and I'm here with an orchid. Now, orchids are very fascinating to many people. You could think of them as sort of the dinosaur superstars of the floral world, the difference being that orchids have not become extinct. Well, at least not yet. And when you look at an orchid, realize that it is an extreme example of plant adaptation to the marketplace of evolutionary competition. You see, all around you, plants are struggling with each other to get the most resources and to make the most seeds and to have the highest reproductive output. Even when plants appear to be sitting still and doing nothing, still, there's a lot of activity going on around them. Plants have to be efficient, and so do all of the parts of the plants. A flower can't just be pretty, even an orchid, because if the flower does not attract pollinators, then it has wasted its time, it is a liability to the plant, and the plant may become extinct because the flowers, just like the rest of the plant, have to pay their own way in order for the plant to be successful. Now, orchids live in rainforests. We're not in a rainforest right now, we're in Oklahoma, but because it's 80 degrees, overcast, it's about to rain any moment right now, and all the mosquitoes around here, and slugs and everything that have gotten on my hands, it feels like a rainforest anyway. But what they are is they are scattered widely so that each orchid could be a kilometer away from the nearest orchid of the same species. And they don't grow in the soil, they grow up in the branches of the trees with their roots hanging down into the air. And so that's the way orchids live. And now we can begin to understand what orchid adaptations are like. First of all, these flowers are really huge for such a small plant. These flowers represent a big investment. They'd better pay for themselves, because if they don't, this orchid is not going to pass on its genes. Also, the flowers are extremely intricate. 3 sepals, 3 petals, but one of the petals has lots and lots of parts to it. It is adapted to a very specific pollinator. I have no idea which one it is, but just one pollinator that is able to carry the pollen from one orchid to another orchid of the same species. But there's even more than that. These leaves right here are not what you would expect from rainforest plants because they're succulent. That's more what you would expect in the desert. But the reason they're succulent is even though it may rain every day in the rainforest, after the rain stops, the sun comes back out, it's hot and dry again. So if the roots were in the soil, then they would branch out and absorb water. But because the roots are hanging out in the air, they have to absorb the rainwater and then reduce the amount of water they lose the rest of the time. And that brings us to the last interesting thing to note about this orchid. This is a root. And the root has a lot of absorptive tissue in it, but it does not have fine little hairs to absorb water. Instead, it absorbs the rain. And there's one other thing that's fascinating about this orchid root. Perhaps you think your eyes are playing a trick on you. It looks like this root is green. Well, it is. That's because roots hang out in the air and they occasionally get sunlight. Why not have chlorophyll in them and use them as a secondary photosynthetic organ in addition to the leaves? Now, it's green. That doesn't prove that it's chlorophyll. If I was going to prove that, I would have to cut off the root, extract the pigment, and do a spectral analysis on it, compare it to the spectra of chlorophyll to be sure. But I'm not going to do that. This is my wife's favorite orchid. Well, I'm working on a book about the subject of plant efficiency and how that helps plants to win in the game of the evolutionary marketplace. But until that book gets finished and is published, I just want you to look at the world in a different way, especially when you look at something like an orchid, to see it in a different way. Don't just see it as a pretty flower, but see it as an extreme and fascinating adaptation that this particular plant has to win in the marketplace of evolutionary competition. This is the man who pretends to be Charles Darwin. Tally ho, and